Hello, good evening to everyone. Welcome to this webinar, Yarn to Circuit, Embedding Electronics in Textiles. So, without further ado, without taking any more time, let me introduce to you today's session. So, today in the current world, right, if you take the textile industry as a whole, it's ever evolving, right? And with the introduction of automation, AI, and so on and so forth, it's such an innovative area where lots of innovation is being introduced. So today we have a special speaker here with us who is not only an expert in that area, who will be able to give you more insight onto the matter. So I hope everyone is thrilled by this session to get insights, knowledge, and expertise from an industry expert. Right. So without further ado, I would like to introduce to you Deepika Priyadarshini, Chair of IRC 2025, and who is the head of QA and a senior lecturer of biosystems, to give the welcoming remarks and introduce the guest speaker. Dr. Deepika, the stage is yours.
Yes, thank you, Harendra. So, good evening, everyone. On behalf of the organizing committee of IRC 2025, I extend a very warm welcome to all of you joining us today for this insightful webinar session. So, we are conducting our International Research Conference for the 5th time this year, and it is our privilege to have with us Dr. Pasindu Lugoda today, a distinguished academic and a researcher, as today's speaker. Dr. Pasindu is an associate professor in the Division of Surgery and Interventional Science at University College London, where he leads research at the intersection of textiles, electronics, and healthcare. His work focuses on developing comfortable, wearable textiles embedded with sensors and actuators, with a particular emphasis on applications in rehabilitation and health monitoring. His interdisciplinary approach combines engineering innovation with user-centered design to create next-generation smart garments that enhance patient care and recovery. Before joining UCL, Pasindu Lugoda was a senior lecturer in engineering at Nottingham Kent University, UK, where he worked closely with the Advanced Textile Research Group within the School of Art and Design. He also held a research fellow position at the Sensor Technology Research Centre at the University of Sussex, focusing on the development of shape sensing textiles for orthotic applications. In addition, Pasindu completed research internships at Microsoft Corporation in Redmond, USA, contributing to cutting-edge wearable technologies. He earned his PhD from Nottingham Trent University, specializing in temperature sensing yarns. Prior to his doctoral studies, Pasindu worked as a textile development engineer at MAS Holdings, collaborating with global brands such as Nike to create production-ready garments using circular knitting technologies. Pasindu has a degree in electronics and communication engineering from the University of Nottingham, Malaysia campus. In this webinar session, Dr. Lugoda will be sharing his perspectives on from yarn to circuit, embedding electronics in textile, a subject that holds immense relevance and value for our participants and this conference. We are confident that his insights will spark meaningful discussions and inspiration to researchers, academics, and students alike. So, without further delay, while thanking Dr. Pasindu for accepting our invitation to host this webinar, let me warmly welcome Dr. Pasindu Lugoda to begin his presentation. Thank you.
So thanks a lot for having me. I'll get started with the presentation. I hope you guys like it. Let me know if there are any problems. let me dive into electronic textiles and what my talk. So yeah, textiles is something that everyone has, right? Everyone wears textiles. You see textiles everywhere on your seats, on your cars. Textiles are basically everywhere. So I know most of you possibly wear underwear. So textiles are everywhere in every aspect in our lives. So the idea is, why are these things that we wear not so smart, right? These are quite dumb in a way. There's no innovation, as in there's no electronics in textiles. You carry around a phone, but you carry around a phone, and there's a lot of technologies like smart fridges, smart ovens, and all this stuff. But your clothes are still quite dumb. So the idea is, why can't we make these smarter? So yeah, the first thing when you hear about electronic textiles is you think about these sort of lighting garments, right? Things that light up. But this is not it. This is not the only thing that electronic textiles can be used for. So the cool thing about textiles is that you can embed any sort of sensor or actuator in the textile, and you wear it everywhere. So you're used to wearing textiles. So you can have a t-shirt that monitors your ECG, your heart rate, or other sort of variables. And because you're used to wearing textiles, and if it's comfortable, you won't even know you're wearing these devices. So you can have like a smart computer on your textile in a way, right? If it's integrated in a nice way, and then you can be wearing it without really knowing you're wearing something that monitors your health. Can be used for GPS tracking sort of stuff, and there's a lot of applications for smart textiles. We'll dive into what I've done so far in this area, and we can see what you guys think about it. So the good thing about having textiles is there's no stigmatization. For example, if you're wearing like a medical device, let's say, I don't know, some sort of medical device that lets people know, okay, you have this medical condition. Maybe people are not confident enough to wear this sort of medical device because you don't want other people to see that you have this medical condition. So the idea is, if you have it on your textile, no one will even know that you have a certain medical condition, and it will be monitoring your textile, your t-shirt. You can be wearing t-shirts and pants, and that can be monitoring your condition. So that's the cool thing about having things in smart textiles. But it's not so easy to make electronic textiles, because there's like three genres that come together. There's textile science, textile engineering, electronic engineering, and material science. And if you're using it for a healthcare application, even healthcare, like biomedical engineering, needs to come in. So it's like a very complicated thing to do, where you combine these different areas to create a single product. So that's where the challenges lie. And we look at different ways of making these electronic textiles. So the first generation of electronic textiles is where you have this sort of massive electronics integrated onto the surface of the textile. So you can see here on your left, there's this lady having like multiple electronic devices on the textile. So this is not really electronic textiles. The problem is, if you have these massive things on your textile, it's not very comfortable to wear, and it's quite heavy. So it's quite difficult. So you won't feel comfortable. So you wouldn't want to wear a device like this. So we've done some work around, so we call this the first generation of smart textiles, e-textiles, electronic textiles. I've done some work in this area as well, where we integrated like strain sensors. So strain sensors is basically when you stretch something, there's a resistance change, and you can measure the amount it's stretched based on the resistance change, and you can use this for movement detection. So we've done some work where we've integrated like stretch sensors on the surface of gloves and used it for wrist movement monitoring. So this is quite a nice application, although you can see it's not really nice to see. You have the sensor on top of the hand, and you can see the sensor. It's not visually appealing, and also it can break. And textiles rub against things and things like this, and it can break quite easily. So it's not an ideal way to integrate electronics into textiles. The other generation, the second generation of e-textiles, is like what we call, where we have these sort of like metal wires and things knitted onto the textile. So the problem with this is, so this doesn't impact the textile's appearance or the feel or the conformability. But when you're using like a sensor or something like this, you want it to have repeatable measurements. But when you integrate these sort of wires into textiles, one of the problems is it's quite hard to get like the same measurement twice. Therefore, we like to go into the third generation of electronic textiles, where we have circuits, miniature chips embedded within the fibers of the yarn. So a yarn, you might have seen, if your grandmother is knitting or something like this, you might have seen they have these sort of fibers that run and they knit together. So this is what you call a yarn. So if you integrate like a electronic chip, a miniature chip, so I'm talking a millimeter or even smaller, a chip within these yarns, you can create electronic textiles with integrated circuits. So let's go into different technologies of making these yarns. So one of the technologies that I did was when I was doing my PhD, we were working with this, I was part of the Advanced Textiles Research Group at Nottingham Trent University. So the idea was to embed surface mount chips, which are like these miniature electronic chips so if you guys have ever taken apart your phone, you'll see there's like a PCB board, and then there's this miniature chips positioned on this PCB board. So the difference here is we take these chips and we take this miniature chips and position it within the fibers of the yarn, and then we encapsulate it, making it completely washable. And then we have packing fibers and covering yarn, covering in the chip, so you can't really see the chip. Say, Nottingham Trent has right now developed a fabrication process for these chips. So this is developed by the Advanced Textile Research Group. And what they do is you can see this sort of thin copper wires, right? So they kind of remove the enamel of these copper wires. Then they put solder paste on these copper wires. If you guys have done soldering, you might know what I'm talking about. And then you use a pick and place machine to place the chips on the wire, then you solder it. So it's almost the same thing that happens when you are using conventional electronics. But in conventional electronics, you position the chips on a PCB board, printed circuit board, but here we embed it within, we position it in a wire. So that's the slight difference. And then the idea is you kind of encapsulate it, so make it completely, you have like a encapsulation, like a micro pod layer. The thing about this is quite small, right? If you look at this picture here, it's almost like 1 millimeter, so you can't really see it. You can see it with your naked eye, but it's quite small. So you can see it's been increased in size because it's been magnified. But once you have this sort of micropod, it becomes completely washable. So it's you can chuck this in a washing machine and still the functionality is not affected. Then the final phase is you cover the fiber. So you cover it using a knit braider. You can cover it using different technologies. We'll look at it a little bit later. And the idea is you can cover this final fiber with the chips, so you can't really see the chip at all. So here's a picture of just a yarn containing one of these chips, and you can't really see where the chip is positioned because it's really well covered. You can see that's my finger. So it's slightly bigger yarn compared to what you might see in a sewing needle or something like this, right? Like sewing threads, but it's got these electronics embedded inside. So one of my work was mainly looking at temperature sensors. So one of the things that we had to look at was what is the impact of embedding these sensors within the fibers? Is there any sort of problem with the temperature measurement? And we saw that there's a slight deviation in the temperature measurement, so you need to calibrate the system. Then there's things like step response, and again, I'm not going to go into too much detail, but there are things that get impacted when you embed these SMD, surface mount chips, in yarns. The cool thing about it is that you can actually, it's machine washable. So you can put it in a washing machine. It works underwater, right? So there's no impact with by the fact that we've embedded it, the way we've embedded it. So one of the areas that I started looking at was this temperature sensing sock for early detection of diabetic ulcers. So diabetic ulcers, you might have seen that Sri Lanka has a lot of people with diabetics. So you might see these people get these massive wounds on their leg. And then what happens is after a while, you need to get your leg amputated because these wounds don't heal. This happens with diabetic patients. So during my PhD, I worked with a startup from the US at the time, and what we wanted to do was develop these socks for early detection of diabetic ulcers. So you can use temperature detection to detect these diabetic ulcers. This was some work that we did. The other cool thing about integrating the yarns with the sensors is that you can make any piece of clothing. So you can make gloves for things like Raynaud's disease. So Raynaud's disease is this disease that ladies get. So when you touch something cold, your blood flow kind of ceases to the hand, and then you have this intense pain that you might feel when the blood flow comes back. So this is one way is to detect the temperature of surfaces and actually act on it. And then also I did some of my work where we put temperature sensors into like a smart bandage or like a wound like a smart bandage. So you can take the map, the temperature map of a wound, so you can see where a wound is getting infected and if it's not healing, what are the problems. So this is some areas you can look at. So here's a quick video just to make sure that you guys are following. Here's a quick video where you can see this was a long time ago, so it's not high quality video, but you can see my friend just touching the fingers of the glove, and these are temperature sensors in the fingers, and you can see the temperature increase in real time. So you can measure the changes in temperature in real time. Another thing that you can do is also embed movement sensors. So you have some sort of movement sensor that is an accelerometer. So your phone, when you rotate it up and down, you can see kind of changes. So your screen changes. So normally in a phone, there's gyroscopes and accelerometers inside in the phone, and it can detect movement. So similarly, what we wanted to do was take these miniature chips, and we wanted to put it in socks, and we asked people to walk in different gaits, so different walking patterns. You guys might have seen that some people have really different walking patterns, where sometimes people walk in different patterns because of certain health conditions. So what we wanted to see is, can just a sock identify these patterns without the input of any doctor? So can you just wear the sock and they walk in their weird pattern, and then can this sock say, okay, you have this condition in this way, right? So without including doctors. So we did a machine learning algorithm, and we asked people to mimic these gaits, and we tested our data set, but it was we got quite good results. So we tested like 7 different gaits, and the algorithm and the machine learning algorithm was able to detect 5 of those different gaits and say exactly which condition these people have, right? The gait, exactly which gait they were performing. So this was quite an interesting sort of result, and we want to develop it further so that we can test it on clinical patients and see if they can just wear the sock and we can detect these sort of gaits. Just checking, can everyone still hear me? Hello?
Yes, Dr. Pasindu.
Perfect, yeah. All right, so just making sure. So the other thing is we wanted to see, so during my PhD, I also worked, like I said, I also worked at Microsoft, and the idea was, can you create these individually addressable LED arrays within yarns? And we did some work there. And the idea was you have this flexible PCB board with surface mount chips that can be positioned on the flexible PCB board, and can you create this sort of individually addressable PCB arrays. So this is another way of making these yarns without, you still have the surface mount chips, but then you have also flexible PCB board. So flexible PCB boards, you might have seen like these phones that can bend. So that has a flexible PCB board. So something like this. So you have these flexible PCBs that you can integrate within the yarns. So the idea was we wanted to create a mass manufacturable technique of making these yarns. So there's ways of creating these flexible PCB boards in bulk. So you can produce multiple of these yarns, and then you use a standard pick and place machine to position these electronics on these strips, and then you kind of laser cut these strips, and then you have the final strips, and then you encapsulate that within the fibers. So here's an example, right? You have this individually addressable LED within a yarn. So you can integrate this into like into a clothing, and you can create this sort of flexible displays. So the cool thing is it's quite flexible, and then you can see here, you lift the textile, and it's all within the textile. So everything is integrated in the surface of the textile. So it's pretty interesting to create. You can have, so I had my first name is Don, which came up on this, but I couldn't get a video of that. But yeah, so you can have certain messages pop up or certain things pop up on your clothing. The other thing we want to try is to remove this assembly chip, the surface mount chip that I was talking about. This is about a millimeter in height. So we also want to remove this one and make completely thin yarns. So the idea is, you might have seen this, if you just look at this thin film electronics, the idea is they don't use chips at all. They use things like paper thin materials, like really thin material, and they deposit the electronic circuits onto these paper thin materials. So you can create these thin film sort of circuits. The idea is you don't have the surface mount chip, but you have a really thin film electronic circuit. So we developed temperature sensing yarns using this thin film material. The good thing is it's even smaller. So earlier the yarn might have been 2 millimeters in thickness. Now it's 1 millimeter or something like this. So it's much smaller in diameter. So it's much better. So we looked at different yarn manufacturing facilities. One was Stretchline Stretchline is also an MAS Stretchline in China, and some other two machines like Brader and Nip Brader to make these yarns. And we wanted to compare the results, and we saw which kind of coating gives the best measurements for our sensor. Again, so these different coatings might be better for different. So for example, for temperature, I think this double covering machine was the best for measurement, but this machine here, it gives a better covering. But in other cases, so for example, where you need like liquids to come in or some sort of other sensor that you're using, you can use things like the Nip Brader. So you can have different applications. Depending on the sensor or the actuator, you can change the covering. So we did some work where we looked at a person doing bicep curls, and then we wanted to see when the person is doing bicep curls, is there a change in temperature? And you can see it actually measures, there's a slight increase in the arm temperature when you're doing bicep curls as to when you're resting. And then we just wanted to show that an application for our technology. One of the things when you're using these thin film circuits is that thin film circuits can bend really well. They can bend around even a hair. But the issue is it doesn't shear. So shear is basically, I don't know if you can see me in the screen, shear is basically one of these properties textiles have, and it cannot drape around the surface, which is one of the properties textiles have, and which is what makes textiles comfortable. So what we want to do was make these sort of yarns even more with the ability to shear and drape. So we developed this new way of doing the thin film sensors in yarns, where we made the size of thin film sensors much smaller, and we integrated that in a yarn. So we did our most recent work looked at touchless sensing in textiles. So the idea is you can have like a magnetic sensor on the textile, right? And then when you bring a miniature magnet, it could be on a ring, or it could be, some people put magnets on their skin, right? When you bring that close, the textile reacts. You don't need to touch, but it's like a touchless system. So here you can see the example, right? There's a glove with a miniature magnet. You don't even see the magnet, tiny magnet in the glove. And then you have the sensors. The positions are marked with these circles because it's hard to see where it is otherwise. And then when you approach it, you can see the sensor measurements change. So you know where exactly you've gone. So think about it in a way for gaming and things, right? We'll show you in a bit. So you can have this touchless interactivity on your textile, and you can use it for gaming or different other applications. So like I said, once it's created, what's the really cool thing is it doesn't impact when you just touch it. So there's no impact by just touching it. You need to approach with a magnet, but it's also quite, you can crush it. You can see my colleague on the left is just crushing the textile. And there's like, you can just, it's a normal textile, like what you can do with a sock in a way. So it can completely deform quite well, and it works underwater. So you can see here when you approach this magnetic sensor with some sort of magnet, you can see it working underwater quite well. And then you can integrate it with gaming, VR gaming, mainly for you guys who might be interested in gaming, right? So you can move around in a VR sort of environment using this. You don't really need it at this point, but just showing that different applications that you can use this for. And you can use your textiles to go around in VR sort of stuff, right? So you can do more complicated. So for those of you guys that are electronic engineers that are here, you can do more complicated circuits and also put it into the textile. You can use these thin film sensors, thin film transistors, and thin film transimpedance amplifiers and things like this. And you can put this also into a textile. So this is also quite possible if you can make it small enough, and then you can insert it. So this takes me to the next part of this lecture, which is actuating textiles. So we can do sensing. Now the bigger question is, can you do actuation? And this is some work that I'm developing now to develop actuating in textiles. So if your textile can actually indicate, like, point to you, tell, okay, there's something happening or something like this could be really interesting. So we did this actuating textile recently, and we published this paper where you can create a textile that actually there's bubbles that bubble up, and in a way it's almost like a finger point to your body. So like if someone's poking you, right, you feel that. So it almost gives that sort of impact where it's almost like someone's poking you, and you can integrate. So you can integrate multiple of these, and you can use this for different applications. So for example, if you're in VR and it's raining and you actually feel your textile actually makes you feel the rain, that's really interesting, right? And think about it for rehabilitation applications and things like this. Some people, and they need proprioceptive feedback. So sometimes their shoulders have gone this way. Someone needs to indicate to them, okay, you need to bring your shoulder back. So it's like a miniature, like a poke, could be useful for rehabilitation as well. And then things like communication with sensory impaired people. So sometimes there are these sensory impaired people that they can't hear, that are deaf, blind, that can't see or hear. So there's some work done by Ted Eagleman that I've seen some time back, where they use these motors to communicate with them using the skin. So you can use your skin and different vibrations of your skin to communicate certain things to people. So you can even train them to understand sentences and things like this using vibrations on the skin, on like your stomach, to indicate certain things. So you can indicate this to people that are deafblind. And this is why we really started this project, to look at how we can effectively communicate with people that are deafblind. So here's an application where you can see the VR rain thing that I was mentioning. Oh, if it plays here. Oh. So here is one of the other things. You can play around with the frequency of the bubbles. So you can increase the bubble size. You can play around how fast you do it. So it could be an indicator. And then you can see when it rains, you can make it feel like it's raining on you in a real time, and it feels like there's actual rain, which is quite interesting, I think. So more recently, we've kind of moved into trying to develop yarn-based exoskeletons. So this is the really new project that I'm doing, and this is my work currently. So the idea is, can you have this textile exoskeletons, like intelligence of robots? Can your textiles be converted into intelligence of robots, right? So this is quite interesting because we can do movement as well. So it can help you with your movement. You can see the textile here move slightly. So it can provide assistance, let's say your wrist. So if you want to move your wrist this way, it can provide assistance to move your wrist, or it can provide resistance for that movement and make it a little bit difficult for you to move that area of the wrist. So the idea is it can provide assistance for your finger movement or your wrist or any of the other applications. So the idea is, can you create like a textile exoskeleton technology that can assist with your movement or resist it? Let's say you want to build a muscle, for example, right? So you can resist the movement. So when you go to a gym, when you lift weights, what you're doing is you're resisting that movement from lifting, right? So you're lifting a weight, so it helps build the muscle. So in the case of rehabilitation, we need to also sometimes, first we need to assist with movements for people who can't, let's say, they have a wrist problem or something like this. You have to first assist with the movement. And then over time, we need to reduce that assistance and then start resisting that movement in order to build that muscle. Otherwise, what happens is if you keep assisting, the muscles in the forearm will start disappearing. So that's also a problem. You don't want your muscles to be gone because you need it for other activity. So you need to build the muscles as well. So first you kind of assist and then you can resist. So the idea is you can create, again, we go to the yarn-based system where you can create these yarns that can bend in a certain way, and you can see it bends like this, and then it can provide the assistance or resistance that is required. And you can combine multiple technologies. You can combine the sensing and the assistance. So you can sense, okay, this person's doing this movement. Now we have to assist and provide the assistance in real time. So think about it. It'll be really, so if you're doing a certain movement, it can think, okay, now this person is trying to move his wrist up. So we assist them. And after a while, it kind of learns from your movements and your rehabilitation journey. It can start resisting the movements and then help build those muscles around you. I hope it's quite clear what I explained. Yeah, so the idea is you can have this sort of sensors and actuators in the yarn type. So you can see here, right? An example. And then you can have multiple bubbles and you can have different applications. You can use different technologies and create really cool electronic textiles. So rehabilitation is one of the applications that can benefit largely from this. But there is other applications as well, gaming, any other training. So if you're training, if you want to learn, so like even educational platforms can be more immersive using these sort of technologies. Yeah, so just a few important things. So again, I know this is a bit of a talk, so I'm giving the talk and you guys are listening, so I'd like to be it to be a bit more interactive. So I want to ask you guys, do you see anywhere where these electronic textiles can be used? And if so, you can tell me once we have the questions. Few things to think about for electronic textiles is that you want the textiles to be highly conformable. So you want, when you're developing these electronic textiles, you don't want it to be too bulky. So this is the first thing you need to keep in mind, but it has to also have the functionality that you require, right? So you need to be functional, but also not so bulky. And then the electronics in ideal situations should be able to go into your clothes without you even knowing it, which makes it really more interesting. And then you you can do all these things, but it has to be durable, because textiles rub against things. You chuck your textile into the washing machine, so you don't chuck your phone into the washing machine like that, right? So you need it to be more durable than your phone in a way. So those are the challenging bits. And then obviously it has to be sustainable. You can't, because textiles is one of the biggest contributors, one of the biggest problems, and which is not impacting the environment. And then electronics is another big problem. When you combine the two, you create a beast. So you need to think of sustainable ways of doing it. And finally, I would say the cost. There's no point of having all this electronic functionality into textiles if no one wants to buy it, right? So, because if it's super expensive, if it costs like £15,000, or I don't know, like quite a large amount, like 100,000, like more than 100,000 rupees for a T-shirt or a sock, you're not going to buy it. It's not really affordable, right? So you need to find the cost balance with the technology. So this is the challenging bit. But again, yeah, I'm more than happy to hear what you guys have to say. And thanks a lot for listening to me. Can you hear me?
Yes, you are audible, Dr. Pasindu.
Yeah, perfect. Yeah.
All right. Right. Thank you so much for that amazing, I would say, lecture presentation. Basically, you told us about so much things that I didn't think about, right? Of implication of textile and technology, which was really amazing, because I'm a person who's not coming from that background. And when I heard some of the things that you were introducing during your presentation, it just blew my mind. Right. So I would like to tell the audience moving forward, this is the second webinar of a pre-conference webinar series of IRC 2015, which will be held on the 12th, 13th of November. So I would like to emphasize on that this is a series of webinars. There will be more to come, more interesting topics such as this, such as more intriguing and expertise such as Dr. Pasindu joining us in the future. Right. So without further ado, right, I would like to move on to a Q&A session, right? So during the presentation or during his discussion, or if anything came to your mind as the audience, the floor is yours. You can direct questions on the chat. You can send it to me directly, or you can just easily unmute and ask yourself. So we have a 15-way Q&A session. So just drop in your questions. I believe Dr. Pasindu is very well ready to answer all of them. Right. So until our audience gathers their thoughts and come up with questions, I have a question for you, Dr. Pasindu, if you may.
Yeah, go for it.
So with all this tech, and there's, if you take an iPhone or iWatch, all have integrated, the tech you were talking about. So why would people shift from the trendy iPhone, like Apple Watches and Fitbits and all of that, and move into textile? Why do you think people would do that shift?
So one of the things is, so one thing we've got used to is carrying this phone, right? Which is kind of like a brick. You carry this brick everywhere in a way, right? So the idea is, can you make it comfortable and wearable in a form factor that is quite nice to wear? So that's why I think there has to be some sort of, actually, for e-textiles to come forward, there has to be a massive amount of investment that goes into it in order to get it out. But I think if you can get it out, you might not need to carry your phone everywhere, right? You might have everything on your T-shirt, right? Or a thing. So that's the cool thing. And compared to things like Fitbit, so there are wearables coming out, Fitbit, Aura Ring, and different rings and different things. But it's one thing is, do you remember to wear all this stuff, right? For me, I always remember to wear my underwear or my T-shirt, and you don't remember to wear, like, if you have all this stuff, it's more stuff you can lose, right? And the other thing is, it only can measure at, like, if you have a Fitbit, it's your wrist, right? So it's estimating your heart rate and things like this using your wrist. But for some applications, if you want to take the temperature of a wound or something, you can't put your Fitbit around the wound. Or if you want to take the temperature under your armpit or certain areas, right? So this sort of stuff you can't do with something that goes around your wrist or your arm, right? So what you need is some sort of form factor that actually reaches every part of your body. And textiles reach most of it. Obviously, you don't wear textiles on your face unless you're wearing a mask, and this, you can have sensors in the mask as well, right? So it's like textiles cover most of your body. So if you look at it, and we have textiles everywhere. We have it on your t-shirts, on your seats, on your carpets. So you can integrate, if you integrate technology into this, everything can be made much more smarter. And the other thing is, if you look at people with dementia, like my grandfather had dementia. So if you look at people with dementia and this sort of thing, they don't want to wear watches and all these things, right? But they would even remove their clothes, but normally they do wear their clothes. So if you have this sort of comfortable thing integrated, you can even sense people like this, and even kids. You don't want like I have a son, you don't want them to, like, it's very rare they'll lose but the t-shirts sort of stuff, they always have it on, right? It's kind of, so that's the approach. That's why I think it should be textiles. But then again, people might say, no, doesn't make sense.
I believe I understood your point of view in that. So which is true, right? Convenience is one way actually you can pitch the idea. Hey, like even though you have the watches you might forget it, but just wearing a clothes and getting the same output of a watch, you just don't have to think about it. Just get in the morning, wear this, go to gym, and you get the same output that you get from wearing a watch. And sometimes the watch could be an inconvenient when you're lifting weights and all, right?
Yeah, that too. Yeah. So it's
Exactly.
the other thing is, if you want to measure exactly location, if you want to like have things like EMG measured on your muscles, or you want to make sure that your muscles not getting tired, or you want to measure temperature, and there's so much research around this where you can measure certain things, and you can say, okay, this muscle is tiring or fatigue or something like this, because you spoke about gym. So you can optimize your workout, right? Using the text, like with the Fitbit, it just gives you your heart rate or whatever. It doesn't tell you. You can still injure yourself doing heavy weights, but here you can optimize your workout by getting exactly, okay, now this muscle is at this temperature this time, right? And maybe you should rest now, and then again go back, or it can giving an informed sort of decision.
All right. Yes. So now we have questions coming in from the audience. One is from, I believe, Dr. Udar Ratnaik. Yes, Dr. Udar Ratnaik, you may unmute and ask the question directly.
Yeah, I'm not doctor. I'm just
sorry, my bad.
Yeah. I'm working as an academic staff member in Department of Textile and Fashion in SLTC. So, when I was listening to your webinar, like, it was truly influential. Right, when I was in a situation like seeking for more topics for the researchers, things like that's truly influential. And I was thinking, once I was hearing your adjustments and applications, so what would be the possibility of collaborating nanotechnology into these applications? Because when I was thinking, is it possible to use nanotechnology, these kind of applications that would make it more lightweight and maybe more affordable? So I was thinking about that. So doctor, could you please elaborate regarding that approach of collaborating nanotechnology with this kind of scenarios?
Yeah, so most of the stuff we're doing is not at the nanoscale yet, because it's at the micro scale, I would say. But yeah, if you're talking about collaboration between us and you guys, I think one of the things that I'm really happy to set up, like some sort of collaboration between the universities and see where we can explore what we can do. So I can show you guys what we've done so far, and see if there's anything that you guys can bring in from your side, and then we can go towards a collaborative like a paper or something like this. So I'm very open to these suggestions and this sort of stuff. Again, we need to make sure it's at a high quality and things like this. And the other thing is collaboration through students, or if you have any, I'm not sure, if I'm not mistaken, you guys don't have PhD students at the time.
No, doctor, we don't have PhD students. We are having 2 degree programs regarding like textile technology and fashion merchandising. Undergraduate students.
We can't, so like with UCL, there is this policy with, so I think we have this policy where people can actually visit UCL and then do like a internship sort of, like a research program for like 3 months, and you don't have to pay anything, but obviously someone has to fund their flights to come here and things like this. So this is there, but then the really interesting thing would be that UCL, like for a researcher, it's very good because UCL is currently ranked number 9 in the world, right? So it's, if you get a chance to work in a university that's ranked number 9, it's quite a nice opportunity. So I recently got an opportunity here as well. So I kind of see that, all the technology and stuff that we can do. So this would be something, some way, if there's any students that are available that want to come. The other thing is obviously there are different, so again, depends on the project. And then there are obviously like PhD programs that people can apply to in order to get in. There is this UCL funded, like the EPSRC funded UCL programs, but these are normally very competitive. I mean, very, very competitive. I don't think I would get in, and I mean in the nicest way, because it's so difficult. I've seen sometimes it's quite tough to get in, but you can give it a go, right? That's the best you can do. The other thing is there's also these self-funded PhDs, which some people do, but this is quite expensive, I would say, like around £100,000 for the PhD for the whole 3 years. But this is quite expensive unless there's someone that wants to work on this. So there's different avenues, like I said, different avenues. I think the easiest one would be to see if we can maybe get a student to work on a project for a year or 2 and try to get a publication, and then we try to go for a grant or something like this, right?
Thank you very much, doctor. That's truly influential also for students and also for the staff. Thank you very much.
Good.
Hi,
All right. I believe.
Dr.
Yes, go
Pasindu, this is Lakshita here, and we had a meeting a couple of
Yes.
weeks ago. Just a general question, doctor. Now, when it comes to Sri Lankan context, what are the opportunities that we have, especially when you consider the materials that we have in terms of printed electronics? Probably we may be able to use graphene oxides or reduced graphene oxides. What is the global applicability when it comes to these kind of materials, and when it comes to these kind of research, since you have quite good knowledge on the current status of the research in this area? What do you think about that?
I think so. I'm not a huge materials person, so I would say I'm not hugely. I wouldn't be able to give you a good answer on which kind of material research is working quite well now and which is quite trendy, right? So I might not be the best person. But one thing that's there currently is that there's a push towards application side in the UK. So research towards application. So if you can combine some technologies together and create something like for rehabilitation or something like this, there's a little bit more funding in this area. So I see there's a gap there. So if you can find, let's say, stroke rehabilitation at the moment, so this is where I'm working at the moment, and there seems to be a lot of funding coming into rehabilitation, I would say, because there's a big problem with the world at the moment. Because I think if I might be wrong in this, I think I read a WHO report that said 1 in 3 people need rehabilitation, and in the West, people are getting older, right? So they're getting more older. So if you can create devices, the problem is you need staff to look after these older people, right? And then to rehabilitate them, and they don't have enough people, right? So this is the problem. And there's not many young people here in a way. That's why there's a lot of opportunities for people from abroad to come and work as carers and things. So but then there's a lot of push towards rehabilitation devices. So I would say
that's a global problem, right? We have an aging population in many countries.
It's also in Sri Lanka, but then we are probably struggling in this way because most of our younger people are here, right? Because shipped away. So this is kind of the issue. So I think rehabilitation tech, that area, there's funding. In terms of materials, I'm not I've not gone for any materials sort of research in a way. So I'm not a huge expert to say, okay, this sort of materials would be quite useful. So I like flexible circuits and flexible electronics, mainly because you can put it into textiles. So that's an area I'm kind of interested in. If you can so you can use these Kapton strips like Kapton is the easiest one, but you can put electronics into any flexible circuit in a way.
And I've seen many people use silver paste in terms of printed electronics. Right.
They do. There's a lot of stuff with printed on textiles as well. The other thing is, I don't know if you have, so you have a textile school, so you have access to textile equipment, right?
Yeah.
So that might be another approach, right, to create this wearable sort of stuff. Because I think it's a bit of a gamble, but I think it's something that possibly is going to take off with smart textiles and things. Again, from what I see, it's just, I think there's a small barrier. I think if someone breaks it, it's going to be like everyone's going to go for it. So it's like one of these points. One of the issues with the screen printing and all this stuff is you need to make it in such a way that, textiles rub against surfaces all the time. Like you're sitting on your seat and your textiles rubbing, and you need to make sure that it's durable, right? So this is the problem with
and the wash fastness as well.
Yeah.
Thanks.
All right. Thank you, Dr. Pasindu, for answering the questions and clearing the doubts of the audience. And thank you, Mr. Dara and Dr. Lakshita, for asking those very intriguing questions. So, also say so myself, English. So moving on, we have coming to the conclusion of this event with the strict time limitations we have. So I would like to formally invite Dr. Sangeet Ratnayaka, the Secretary and Senior Lecturer Agricultural Technology, to give the vote of thanks.
Okay, thank you, Mr. Haranger. So thank you very much for attending today's webinar from Yarn to Circuit, Embedding Technologies in Textiles, presented by Dr. Pasindu Lugoda. And also we extended our sincere gratitude to Dr. Lugoda for sharing his expertise and shedding light on such an innovative and rapidly evolving field. So thank you very much. And finally, we also want to thank each of you, our participant, for your time, interest, and thoughtful engagement. So throughout this session, and because your presence truly contributed to the success of this event. So thank you very much for all. So, and we hope you all found the discussion insightful and inspiring. So we look forward to welcoming to our future webinars and continued conservations in emerging technologies. So thank you very much for today. Have a good night.
Thanks a lot for having me. See you. Bye.
Thanks, Dr. Pasindu. Bye-bye.
Bye-bye. Thank you all. Yes, and before we conclude the session, there is one more message I would like to share with you all. So first and foremost, I would like to thank you, the audience, Dr. Pasindu, Mr. Dara Ratnayaka, Dr. Sangeet, and Dr. Lakshita for joining in, as well as the audience. So this is, as I said, this is the second webinar of a series of webinars. The next webinar will be introduced in the coming weeks. So keep tuned to our social media and our news bulletins. We will definitely give you more insightful and impactful webinars as to it. Thank you all. Keep tuned to the SLTC social media and see you in the future.